hydrogen peroxide is an unstable compound that resembles water. Water's formula is H2O, meaning it has hydrogen bonded to an oxygen bonded to a hydrogen. Hydrogen peroxide is more interesting because it is right here, and it has hydrogen bonded to an oxygen bonded to another oxygen bonded to a hydrogen. This piece right here is known as a peroxide. This is an inorganic peroxide, meaning it does not contain carbon. Neither of these are carbon. And this is really unstable. It just wants to oxidize anything. Now, there is a way that if you take H2O2, or hydrogen peroxide, then you add some kind of catalyst, you can get H2O plus oxygen. And that H2O plus oxygen just means water plus oxygen gas. It comes out the solution as a gas. So that means that we can split apart hydrogen peroxide using a catalyst. And there's multiple catalysts, but I decided I'm going to use manganese dioxide. I have it in here. M&O2. So it's on the top. I extracted it from some old lantern batteries. And I also got carbon rods out of that. So, yeah. I do not advise you to do this at home. Depending on the concentration of hydrogen peroxide, this could be dangerous. Manganese dioxide is also really dirty, especially if you get it from batteries, because it contains a little bit of carbon, and it will stain anything. So, to get this in the Erlenmeyer flask, we're going to do a classic technique of you pour some out on paper, a bit more, then you fold that paper like you would a taco, and then just pour it into here. So you fold it by the bottom, and just pour it in, and get all of it. And there we go. Now it's all in there, ready to go. Now, we have hydrogen peroxide. Here, I'm going to pour it in, and it should start to bubble. Now, right now, we're producing oxygen gas coming through this tube. And it's hard for you to see. You can see a tiny bit of steam, but we can put this in water. You can see how it totally bubbles. Now this bubbling of oxygen gas can, if you light a match, then put it out, it can relight it, even if it's just slightly red. So, after hearing me talk about hydrogen peroxide, you may be thinking of another common chemical reaction called elephant's toothpaste. Elephant's toothpaste is the exact same reaction I previously mentioned, except the oxygen bubbles, instead of just being released into the air, they're trapped by soap particles in the solution. So here, in a different flask, this one is not a vacuum flask, I have some manganese dioxide. It's not soluble in water, but it's pretty fine, so we can just make a suspension. So it kind of looks like it's dissolved, it's not really though. And we also have soap and a tiny bit of water in there. So that's just that. But then this, it's just the same flask as earlier, so I don't have to wash multiple things, but it's just hydrogen peroxide. Then we can slowly pour it in using this tube right here into this reaction, and it should start to bubble out. Now, I have taken the proper safety procedures, make sure that when this spills over, it's fine to get on the surface. This is still 3% hydrogen peroxide. It's not anything super hazardous. And it shouldn't get too hot, the reaction, so it should be fine. Pour it in. Stir, and pour in just the rest. Okay, and here it goes, it's erupting. So these bubbles are all oxygen. Oh, can move that, touching the dry area. Pop. So you can see here, it's totally erupting. Just what I wanted. So all these bubbles should be mostly oxygen. They're just trapped in soap. Okay, thank you for watching The Good Chemist. See you later. Look at that. It's completely coming around the entire flask. I'm just trying to clean up here and then sort of look cool, so I want to record this. Thank you for watching The Kid Chemist. See you later.